Alright, so this will be the review video that you can use in preparation for your exam. The coverage of our exams, the third quarter exam, is a little bit short actually. We only have linear equations in one variable. Then we also talked about linear inequalities in one variable. So we discuss about the properties to prepare you with the skills in order to solve word problems for specifically linear equations. So, going back, what is a linear equation? You've learned that linear equation are equations that um, has one variable. That's why it's called linear equations in one variable, and the highest exponent in the equation is equal to 1. That's why it's called linear equation. So um, to represent linear equation, we actually kind of look at it as a weighing scale here, and which the scale has two sides, the left side and the right side. The objective of linear equation when we solve it is to make sure that both sides of our weighing scale is practically the same or equal. So in this case, for example, if you're going to weigh in x plus 4 on the left side, which would equal to negative 8 on the other side, what would be the value of x? So here, we will be looking at the value of x that when added to 4 will equal to negative 8. And so in order for us to solve this, we need the help of our principles of equality, which, if you can recall, are the following. So we have APE together with SPE. APE stands for addition principle of equality. At the same time, SPE is called subtraction principle of equality. We also have the MPE and the DPE, which is the multiplication principle of equality and division principle of equality. Now, once we know these principles, we actually have the permission to do some manipulations on our equation in order to solve for the value of x. But I hope you did not forget as well that another main principle that we are following in order to solve the equation is to simply isolate the variable. Isolate the variable in order for us to solve the variable. So, let's begin. Let's try to solve this first. Alright. So, remember, isolate the variable. So, how do we do this? First, we copy the equation. So, you have x plus 4 equals negative 8. Alright. In order for you to isolate the variable, you have to use the principles. Now, 4 here is added to the variable. And in order for you to isolate the variable, 4 should transfer to the other side. Since it's the operation between the variable and 4 is addition, we use either addition principle of equality or subtraction principle of equality. So, in order to isolate that, we have to subtract 4 on both sides of the equation. So here, you're left with x equals negative 12 because you have a negative 8 and a negative 4. So since the variable is already isolated, therefore, that is your final answer. Right? So we have here a couple of examples left. So like in this case, so try this one. You have 9x plus 3 equals 21. So same thing happened. Here, in order for you to isolate the variable, you have to use both principles, APE and MPE. First, by the way, let me go back to when are you going to decide, or which of APE or SPE and DPE and MPE should we do first? The answer is we should do first APE and SPE method. So here you have a 9 times x and you have a plus 3, so you should do first minus 3. All right, so here 21 minus 3 becomes 18, and last to go is the division of 9 to cancel it, so x is equal to 2. Another example. So what if it's going to be like this? Okay, so let's try this one. Let's try to erase some of the things here. Okay, here in this example you have actually a presence of a grouping symbol, which is you have x minus, so you have this parenthesis here. So first step, if you have grouping symbol, is to remove the grouping symbol before you isolate the variable. And you just have to be careful when you remove grouping symbols, because before the grouping symbol, if it's a negative, you have to distribute that negative sign inside the grouping symbol. So here 5 becomes negative and x becomes positive, because you have to distribute the negative sign inside. Once you're done with the you call this one, once you're done, get rid of your grouping symbol, then you may proceed to the isolation of the variable. So as you can see here, you have two x's on the left, so you can combine them. All right, so there's no need for you to change either of the sign of this x and this x, because it's on one side. So simply it's going to be 2x. What happened here was negative 5, we transpose it to the right side, so it becomes positive. So this will be 2x. 1 plus 5 is actually 6. And after that, we divide by 2 to cancel. 6 divided by 2 is equal to 3. Okay. Last example would be, what if we have a fraction? What if we have a fraction? So here, this example, same thing applies. You have to first isolate the variable. So here, first step, we simply copy x over 3, and we know positive 1 goes to the other side. So that would be 7 over 15, and 1 becomes minus 1. Now take note that if it's a fraction, you have to use your LCD in order to solve this. So 1 actually, if we're going to make it a fraction with same denominator with 7 over 15, will be simply equal to 15 over 15. So to rewrite this, you can write it as x over 3, 7 over 15 minus 15 over 15. Okay, so to simplify, we have x over 3 equals negative 8 over 15. Fractions with common denominator, you simply add or subtract the numerator and copy the common denominator. Now, how do you get rid of 3 since it's divided to x? It's divided to x. It's x over 3. Simple. You just have to reverse the operation. You have to multiply in order to cancel 3. So this will be simply x. On the other side, this is as good as multiplying by 3 over 1. So that would be negative 24 over 15. You don't have to worry actually if there are fractions involved. Just follow the steps. First, isolate the variable, then use your principles of equality. Now, next is on linear inequalities in one variable. We follow the same principles. If equations have addition principle of equality, here we also have addition principle of inequality or subtraction principle of inequality. Same is true with that. Multiplication principle of inequality and division principle of inequality. Okay, now here we use a variety of symbols. So you have this one, this is greater than. With this symbol here below, you call that greater than or equal. This is less than, and this is less than or equal to. We also use number line to represent our inequality. Remember, the main difference between equations and inequalities in the number of solution. In equations, we only have one solution, while inequality, we have many solution, actually infinite. So if, for example, you have x less than or equal to 2, to represent that on the number line, you have to shade first 2 because that's your reference point. There are two ways of shading it. You have solid shading. Solid is if there's an equal to sign, and it's empty if there's simply less than or greater than. So you have here the direction of the shade goes to the left because it's less than. All right. So let's try some examples and solve them. So let's say, for example, number 1, you have x plus 5 less than 7. Oh, by the way, still the same thing applies. We isolate the variable in order for us to find the solution. So going back, this becomes x. The sense is less than, and we know that we have to transpose that to the other side or use the API and SPI principle. So this will be 7 minus 5, and your answer is x less than 2. Okay. So if you be asked to represent this on a number line, then you know what to do. Let's go to the next one. Let's say, for example, you have 3x plus 4 greater than or equal to 9. Same thing applies. So you have here a plus, 4 is added to the variable, and 3 is multiplied. So between the two, we use first the addition or the subtraction principle before we use multiplication and division. So we transpose, that becomes 3x greater than or equal to 9 minus 4. Then you're left with 3x greater than or equal to 5. And last to go is division by 3. So x is greater than or equal to 5/3. Now, in a case that you have a fraction answer, you simply have to check if the denominator divides the numerator equally. If not, you have to check if you can reduce it to lowest terms. If not, then that's the final answer. In this case, 5/3 is the final answer. All right, down to the last example. Let's clear this one first with the ink. Okay, last example would be 2x minus 8 less than or equal to 4x plus 2. Now you can see here that you have two terms with variables on both sides of the inequality. So you have to choose when you isolate the variables whether you group them together on the left side or the right side. So let's say you're used to grouping them in the left side. So this will become 2x here minus 4x. And that would therefore mean you have to group all the terms or the constant terms on the right side. So this becomes less than or equal to 2 plus 8. Okay, 8 here coming from the left going to the right becomes positive. Now, this is something that you have to check. Negative 2x, because 2x minus 4x is negative 2x. Okay, so this will be less than or equal to 10. Now, what you have to divide on the other side would be negative 2, so that we will be left with a positive x. Here, you also have to divide by negative 2. Now, this is something that you have to remember if you're dividing negative numbers and you are dealing with inequalities, because the rule says you have to change the sense. So in this case, it's less than or equal to. This will become now greater than or equal to negative 5. Now, this rule only applies when you divide a negative number to your term with a variable. The sense would change. A concrete example would be if, for example, you have a 4 which is greater than 2, this statement is true. if, for example, you either divide or multiply this by a negative number, say negative 1, 4 becomes negative 4, and 2 becomes negative 2. Comparing them now, you can see that the right side is actually the bigger number compared to the left side. So this makes a statement true. That's the same principle that we follow in order for us to have an accurate answer when we deal with linear inequalities. All right. Now, for if you're asking for videos regarding the word problems, we only have two word problems involved in the exam. We have the number problem, including consecutive numbers, and you have age problem. So you just have to go back to the previous two videos that I did in Schoology. So I wish everyone good luck for the exam. Thank you and goodbye.